What the crap, Dragonite? You haven't made a GameMaker video in like a year, and now when you finally do, it's about something boring like computer science? Yeah, whatever. So before I start, this is going to be a computer sciencey video more than a game dev video. If you are not familiar with terms such as data types and floating point and 32-bit integers, I'm going to be making use of those terms in this video, and you may want to be familiar with them. I can't say I know how many people that's going to include. I am familiar with those things because I have taken classes in computer science. For those of you who maybe have not done that, I don't know if that's something that you would know or not. And if that turns out to be a thing that people want me to talk about more, I will be willing to do that in the future should it come down to it. But anyway, buffers. Most of you are probably familiar with arrays. You have an array in GameMaker Studio 2. You can define them like such. I want to make this text bigger because that is a little hard to read in a YouTube video player. You can define them like array equals brackets, say 1, 2, 3. And this allows you to do things like access multiple elements in a single variable. So you could access simply array of index 0 is going to it's going to contain a value. You can put a value into it with the equals operator, or you can get a value out of it like something equals. And you can do all kinds of cool things like looping through them. Under the hood, arrays in GameMaker are pretty weird. They're technically a data type themselves, much like a string or a real number value, instead of just being a section of memory like they would be in other languages. If you're familiar with languages such as C or C++ or something, you're probably aware that in some of those languages you're allowed to have just blobs of memory that you can do whatever the crap you want to with. Buffers are basically GameMaker's answer to that. They're a step back in terms of abstraction from arrays, maybe more than a couple steps back in terms of abstraction from arrays. There are uses for that. You can read them and write them to files lightning fast. Most of the time, if you wanted to read or write a large amount of data from the hard drive, it would take kind of a long time for reasons that I will not be getting into right now. If you're into networking or multiplayer games, you basically have to use buffers as far as I know if you want to be able to send data over a network connection. If you want to do certain things with DLL extensions, you would have to use a buffer to send information to and from the DLL. There are a number of things that you can do with these things that you can't do with just a regular array. So, about making one. They are lower level than arrays, but you have to create them with something more similar to a data structure. There's the function buffer create, and it takes a couple arguments. There's the size of the buffer, and this is going to be how big of a blob of memory that you're allocating. Blob is the technical term. Don't let anybody tell you otherwise. There's the type. There are a few different types of buffers that you can make. I'll talk about them later. For now,
Hey.
I'm going to go with buffer fixed, because this is probably the most common one that you'll be using. Possibly not, depending on what you're using it for. And the alignment, which, again, I'll be talking about later. But for now, we'll just be using one.
Hey.
Putting stuff into the buffer and taking it out is called reading and writing, or in some cases, peeking and poking, which I find hilarious. Because I love the mental imagery of taking your finger and poking your computer monitor to insert data into a certain spot in memory. So, as I was saying, we'll put some things into the buffer. I'll say buffer poke. The index is going to be the buffer that we created. Again, you treat these not unlike you would a data structure. The offset, we'll put our information at the beginning of the buffer, so the offset will be 0. The type, this is where data types that I mentioned at the beginning of the video are going to come in. As you see here in the little help dropdown, you have a bunch of different data types. You have a Boolean value, you have a floating point, a 16-bit floating point value, a 32-bit floating point value, signed 16-bit, signed 32-bit, signed 8-bit, and at the bottom there are unsigned 8, 16, and 32-bit values, as well as 64-bit, which, I mean, if you want. I'm going to go with, let's go with signed 32 for now. This is a basic int like languages like Java or C++, or other statically typed languages. And the value, let's... I'm lacking creativity. Let's just write the value of 500 into the buffer. And we can do this a few times. Actually, before I do it again, I'm going to demonstrate this working. In the draw event, go away, description text. We can say... We can just draw the value on the screen at, how about 32, 32. This will be the upper left, and the value will be buffer peak. The index is the buffer because buffer is an instance variable. Offset will be 0 because that's where we put it. And the data type will be, what was it, assign 32? Okay, so we'll see this in action. This project does have an object in the room, doesn't it? Well, I'll find out in a minute. Okay, so the value of 500 is being drawn at the top of the screen. If you're thinking like arrays, you may want to put another value at, for example, position 1. Let's make this, I don't know. We have 32 bits to play with. Let's go big or go home. 400, that's 40, 400 million. If I can count out the zeros properly. Is that the right number of zeros? I think it is. Okay. Why is it telling me there's an error? Okay, I've worked with big numbers in computers before. You don't need the commas to separate groups of 3 digits when you're programming. Okay, so let's do that again. On the next line, we'll get the value out of position 1, which will be much the same thing. And if this does what we want it to, it will show 500 on the first line or whatever it was, and then 400 million on the second line or whatever it was. And as you can see, that's exactly what happens. Okay, this text is a little small. I might want to increase the font size or something. I'll do that later. So if you're wondering what that's all about, this is where the low-level memory management comes in. A signed 32-bit integer is, as the name implies, 32 bits wide. And yet a single value in computer memory is only 8 bits wide. Again, if you have a background in computer science, you'll know exactly what's going on here. A 32-bit value in a computer takes up 4 bytes of memory, which means that when we poke this value into the buffer, it's actually taking up not only address 0, but also address 1, 2, and 3. And likewise, when we write this value into the buffer, it takes up not only address 1, but also address 2, 3, and 4. And then part of this 400 million starts overwriting part of the 500, and then bad things happen when you look at the decimal representation of what is actually stored in those spaces in memory. So, that is the extremely long way of saying that instead of putting this 400 million value into the buffer at position 1, we should put it in at position 4. And instead of writing it in at position 1, we should write it in at, read it out at position 1, we should read it out at position 4. And now, if I were to run the game, I feel weird about calling it a game because it's more of a demo. But now, if we were to run the demo, 500 and a 4 followed by a bunch of zeros is what we get. Okay, if computer memory was not on your brain before, it sure is now. So once you understand how the data types work, you'll know exactly what to do with these other buffer data types, whether it be floating point or integer or assigned or unsigned or anything. The extremely oversimplified explanation is that whatever address you write something into the buffer is the address that you should write it out of the buffer. So in this case, addresses 0 and 4, and whatever data types you write into the buffer, you should also read out of the buffer. So instead of trying to read out a signed 32-bit value, if I were to let's go with an unsigned 16-bit value, just for fun. This would not produce the correct results. Exactly what incorrect results it will produce depends on something called the Endianness of how GameMaker writes stuff into the buffer, and it looks like GameMaker multi-byte values are stored as little endian inside GameMaker. And I won't bore you with exactly what that means, but you can see that this is 500 is what we put in, but 33,792 is decidedly not what we put into the. I'm going to take the chance that if you're interested in Endianness, you probably will be on the scope of this tutorial, and if you're not interested in Endianness, then I don't need to say anything else about it. But I will anyway. The word Endianness actually comes from the Jonathan Swift book, Gulliver's Travels, which involves people going to war because some people like their eggs big end up and some people like their eggs little end up. And because Endianness in computers involves the byte order that values are stored, you get like little endian and big endian, and God, I have no life. Okay, so anyway, you can see what happens if you don't peek and poke the correct data types. There are other ways that you can read and write stuff into and out of a buffer. You could, if you wanted to treat a buffer like a file where you put stuff in sequentially and you don't concern yourself with the exact addresses, you could buffer you could buffer write, buffer, let's go with, let's do floating point numbers this time. 32-bit floating point numbers, which is a GameMaker real, which is what you'll be using most of the time if you're doing floating point numbers. And the value can be, let's go with, I don't know, 65 point, I'm gonna just mash the number pad a little bit. Okay, so we're going to write that value in, and then we're going to write, how about, let's do an unsigned 8-bit, for a little reason other than that it was the first type that came to mind. And for that we can put in something like, I don't know, 162. Why is that a special number? I don't know. That's how many games are in a professional baseball season, I guess. And then, instead of saying buffer peak, we can say buffer read. And this takes the buffer index and the data type, but it doesn't take an offset. This will, again, kind of treat the buffer like a file in that you read and write stuff sequentially.
Hey.
And when you read or write, you advance the position that you're reading or writing to or from. I'm not going to pretend that this is going to work the way I did earlier. If I were to run the game now, it would just not work. As you can see, it drew out zeros instead of whatever numbers that I tried to put in, and then it crashed because I tried to read from outside the buffer. This is basically a more polite version of the seg fault in C. And that is, once again, because one, I am using the incorrect data types here. I need a F32 and a U8. Okay, F32 and U8. Let's get that straightened out before I do anything else. When I just write the values into the buffer, I write the 32-bit float, the read-write head goes to position 4. I write the unsigned 8-bit, read-write head goes to position 5. In this case, if I were to do that, the read-write position would go to position 5 plus 4 is 9, and then 9 plus 1 is 10, which is the end of the buffer. When I actually did it, they were U16, so it would have gone 7 and 9. And then in the next frame that I tried to draw, it would try to read 2 bytes from position 9. There is not enough space in the buffer for that. It overflows and throws the error. So with that said, every time you use buffer write and buffer read, it is a good idea to, before you start, use the buffer seek function. And this is going to go take the buffer index. It's going to take the base, which is going to be either buffer seek end relative or start. Buffer seek end goes to the end of the buffer and seeks backward. Buffer seek relative stays where you are but goes... Buffer seek relative stays where you are but advances ahead or backwards based on the current position. And buffer seek start, which is the one that I usually end up using, just goes to the front. And the offset is just the index that you're seeking to. And this will be relative to the end, your current position, or the start. So now when I run the demo, there we go. We read out 67 point whatever it was. There we go, 65.8, I'm sorry, and 162, which is what we wanted. Cool. So that's essentially how you'd use a buffer. As I said, I like to think about these as better arrays because arrays in GameMaker are really weird. I think if you were to whip out a stopwatch and do a speed test of this, the buffer access would actually be faster than array access because they are because there are fewer layers of abstraction on top of each other. I'm not going to test that theory right now. But if you are a person who tends to be very concerned with speed and you do use a lot of arrays, that could be worth keeping in mind. Other things, DLLs, networking, Vertex buffers if you like 3D graphics or other complicated drawing shader stuff. Vertex buffers, as the name implies, are indeed types of buffers. And then my personal favorite, I mentioned this earlier, is that when you write to files, it tends to be slow. I'm going to, let's just, I don't like the key pressed events, but I'll use it anyway for the sake of the demo. Let's say when I hit space, let's try and write, say, 100,000 values, 100,000 zeros to make it simple to a binary file. And that's about 100 kilobytes, which shouldn't be unreasonable. Shouldn't be unmanageable, but it shouldn't be unmanageable. It shouldn't be unmanageable, but it's not negligible either. So let's say var f equals file bin open. It's been a very long time since I've used the binary file functions. The file name will be, how about data.bin. It doesn't matter what you call it. It doesn't even matter the file extension. Call it whatever you want. And what's the mode? I want to say 0 is write, 1 is read, and 2 is read and write, but I just want to be sure. Okay, 1 is right, not 0. Mode is going to be 1. Let's close it when we're done so that we don't leak input-output streams. File bin close. And in the middle, we'll just repeat, what did I say, 100,000? File bin write byte. So that'll be the file, and we'll just, it doesn't matter what byte you write. Let's make it a, let's not make it a 0 so that we can see we're actually doing something. Let's make it a 10. Okay, and we'll see how long this takes as well. We can save RT. I love this get timer trick if you ever want to like benchmark how long code takes to run. And then at the end we'll show message. Okay, so for those of you who don't know, get timer returns the number of microseconds that the game has been open. So if you compare the number of microseconds the game has been opened at the end of this block of code to the time at the beginning, you'll see how long it took this section of code to run. Okay, let's do this. Okay, and when I hit the space bar, it took 192,000 and change microseconds for this to run. So that's 192 milliseconds because get timer returns microseconds, or millionths of a second, which is about 0.2 of a second, which again isn't bad, but we can speed that up. So if I were to take this, get rid of it, and say, the word buffer is already an instance variable, and while I can reuse that for a local variable, it's probably not good practice. Let's call it file buffer. So we'll be doing buffer create, and the size, instead of 10, is going to be, what did I say, 100,000? I think that's the right number of zeros. We'll make it buffer fixed because I don't really need anything more complicated than that right now. And the alignment, again, is going to be 1. Oh, by the way, I should, let's see. Yes, I named my F driver specs. Go ahead, laugh. Let's go to GameMaker local storage. This project is running in buffers, and indeed we have data.bin, which is, as you can see, 100,000 bytes, 98 kilobytes. And if I were to open this in if I were to open it in Notepad++, it's not going to look like anything. I think the ASCII value of 10 is a new line. Let's open it in a hex editor instead so you can see the actual values. God, how do I do this? And you can see it's full of 0 A's, which are the hexadecimal representation of the value 10, which is what we put in. So cool, we have 100,000 of those, and they're completely useless, because why would you want that? Alright, the buffer method. So now instead of saying file bin write byte 100,000 times, we'll simply say repeat 100,000 again, and instead of writing them to the file, we'll write them to the buffer. Oops. File buffer. The type is going to be, I guess, one of the 8-bit values, and the value is going to be 10. Okay, so the buffer is now... I think you can also, if you wanted to just fill the entirety of a buffer with a certain value, you can say buffer... Clear? Is that a thing? That is not a thing. Okay, never mind. So anyway, to write it to the hard drive, buffer save, file, buffer, the file name can be, let's say, buffer.bin. And the functions buffer save and buffer load, which is what you do to do the reverse to get information off of the hard drive, they just grab the data in one go, so you don't have to worry about opening or closing the file or anything. Okay, we'll run the game. We will see how long this takes. And elapsed time is 16,000 microseconds. So that is less than 1/10 of the amount of time that it took to write the data to the file that the binary file method did. And as you can see, they're both the same size. If I were to open it up in ye old hex editor, just like before, it is filled with a bunch of 0 A's, which is the value 10. Same outcome, it takes 1/10 of the amount of time to execute. And as an added bonus, GameMaker's binary file read and write functions are really kind of bad. The only values that you can read and write to a binary file are unsigned 8 bits, so byte by byte. If you wanted to read or write a 32-bit integer, you would have to do the math yourself with a lot of bit shifting and that kind of thing. And if you wanted to read or write a floating point value or fraction, then I'm sorry, because you would have to do that yourself, and that does not sound like my idea of a fun time. I've gone on for long enough. That's the basics of buffers. I did say I would talk about things like the buffer type and the alignment, and there are a bunch of other functions that relate to buffers that you can use. But since I don't really want to put up a video that's an hour long, instead I'm just going to make a second video on the more advanced things that you can do with buffers. So, I hope you all enjoyed that. My name is Dragonite. There's only like a dozen lines of code in this example, but I guess if you want it, I'll put it up for download in the description of the video anyway. And I will see you all later.